Hello everyone. I just wanted to make this quick footnote, and I'm a little sad because I'm doing this the night before our final, but I think I should go over a little bit more about three-phase because it's a bit clear that some people are struggling understanding the theory behind it. The first thing I want to say just about my previous video is that I did make a mistake. I did write that V peak is equal to 1 over root 2 of V RMS. This is wrong. That 1 over root 2 should be on the other side. If you are in doubt, always remember that RMS will always be smaller than the peak. The same thing is with I. So it's going to be 1 over square root of 2 I peak is equal to I RMS. And indeed, 1 over square root 2 is going to be 0.707. So IRMS and VRMS are going to be lower than the peak. So it's just one thing I really want to keep in mind. Again, there isn't anything more to RMS than this. If you have stuff in RMS, you convert it to peak. If you have peak and the formula requires RMS, namely the power formula, so it's going to be VRMS, IRMS asterisk. All you have to do is convert peak to RMS. That's it. So I wanted to go over the delta, the sort of direction of the direction of the power source. So some people were a little confused about this one. And I'm going to draw these from scratch. So let me just move these to the side, out into the middle of nowhere. So first thing I want you to write down when you get these. Sadly, I already drew over these, but pretend this wasn't there. Let's make this super large. Let's erase this. So we can draw it ourselves, because you're not going to be given it on the exam, right? So, looking over here, we have A, B, and C. Here we're going to define this voltage source as the positive is going to A and the negative is pointing to B. VAB. On this bottom one here, the positive is pointing to B, the negative is pointing to C. So this is going to be VBC. And same thing here. This is going to be VCA, right? Because the positive is pointing C, the negative is pointing to A. It's going to be pretty much the same setup every single time. We're going to do the same thing here, VBC and VCA. Now, the next thing you're going to want to do is draw yourself a diagram. You might be able to figure it out in your head or mathematically, but it's easier to show what I'm sort of talking about through a mathematical diagram. Let's use green here just so that looks nicer. And now I want you to plot these lines. You don't worry about the magnitude because they're all the same. What matters is the degree. Yeah, the phase. So over here, the first one, we're going to draw this out. It's going to look more like that. It doesn't really matter too much as long as you're in the right ballpark. This is going to be VAB. And then next we're going to draw VBC, right? 30 degrees here. BC is 150 degrees. So just like that, 150 degrees. It all comes from the positive right direction, right? And then you have VBC. We already did VBC. Let's write that down, VBC. And then we have VCA. This is going to be negative 90 degrees. Now let's strike out the second letter here. Just look at the first letter here. And now work clockwise. So what's going to happen, and how's a good way to show this? Okay, right? So this is sort of, this is what we call the real part, right? This is the imaginary part, right? So if we just have, say, voltage is 5 volts, then it's all going to be pointing in the real. As we start adding, complex, imaginary, it starts pointing in different directions. But we call it real because that's really what we're looking at that exact moment. So as this phase will rotate counterclockwise, right? So what happens when we rotate counterclockwise? We're going to see C, then B, then A, and then back and forth again. You see this? So here we're seeing VC. It's a little off center, but you get what I mean. Sorry, that's VB. VB. You see VB, then you see VA, then you see VC. So the pattern here, I'm going to start from A's A, C, B. And then this repeats A, C, B, A, C, B. So when we have A, C, B, we have a negative system. This is just something that you pretty much have to remember. It is a negative system when you see A, C, B pattern. We can shorten that down to A, C, B. If you get in Y, if you get like a Y, so this is in delta configuration, but if you get just Y, you can do the exact same thing, except instead it's going to be N. You do the same process. So let's draw a Y here, for example. This is plus 0, plus negative, plus negative. This is B, this is C, this is A. And you can literally just copy these exact numbers and you'll do the exact same process and you'll get the exact same correct answer. 1/5, this is VAC, VAN. VBN is going to be 23 with a phasor of 150. And this is going to be 23 with a phasor of negative 90. This is going to be VCN. And if you draw this out, you're going to get the exact same graph, except these second letters are going to be N's. But this doesn't change the graph. It doesn't change your answer because you're ignoring the second letter, right? So this is still going to be a negative system. Now, let's take a look at the one that I did on the study hall here. Let's draw it out. So we have our axis here. We have VAB, which is this here with a degree of 25. Let me do that in green so you can see separate from the axes. This is 25 degrees. It's VAB. VBC is going to be right over here, negative 95. Again, the exact degrees don't really matter. And then this here is going to be 145 degrees. These are 120 degrees apart. It's fine if you're off by 60 degrees then, right? As long as you're not drawing in the completely wrong place, you're going to get the correct answer, right? It's going to be VCA. And once again, this is what we are seeing. This point, whatever's pointing this direction. And if we rotate this around, we're going to see B, then C, then A. B, C, A. Starting from A, what is the pattern? A, B, C, A, B, C, A, B, C. This is positive. So these ones you have to memorize. ABC is positive, ACB is negative. Now, we have to then generate our sort of like table that we use. These tables, right? This formula derivation, I did it correctly on the study hall. You can just see how I did that. But these ones, you don't actually need to memorize them, right? Let's take a look at here, right? This is positive. It's negative. What do we see here? So we have AN at a phasor of 0 degrees. So let's rotate everything so that A is pointing towards 0 degrees, right? This is 0 degrees. What is this angle? This is 120. VCN is going to be offset 120, positive 120 degrees from AB. What is this angle here? This is negative 120 degrees. VBN is going to be negative 120 offset from AN. And the exact same thing occurs over here. Let's rotate the system so that AB is pointing towards 0. There you go. What is this angle here? This is 120 degrees. And you can do this mathematically as well, right? This is 150 minus 30. This angle here is going to be 120. So VB is offset by an angle of positive 120 degrees. Look at CN over here. This is negative 90 and 30. What is this degree over here? You can do some math. I hope you can. Negative 120 degrees. Remember, because you're always going from 0, right? Let's draw those lines here. Negative 120. That's it. The rest is trivial. I guess trivial. The other one that I want to mention that I did forget to mention because it was kind of so easy that I kind of forgot is delta loads. So, frankly, the easiest is when you have a Y set up to a Y. Oh, I don't think I'd ever explained that. Did I? Well, that's okay. You probably understood. This is a delta. This is a delta configuration because it looks like a delta, and this is a Y configuration because it looks like a Y. And we're doing all of that to turn a delta into a Y. Anyway, the easiest systems go from a Y source to a Y load. And I showed you in study hall how to convert a delta source into a Y source. The delta load to a delta Yes, it was converting a delta source to a Y source. However, the question already had the load in a Y configuration. There is a question here. For example, over here, as you can see, the load is not in a Y format. It is in a delta format. And, well, you see it right here. That's a formula. So if you have a delta like this, let's connect that up. The connections don't really matter here. It's going to be Z delta, Z delta, Z delta. They're always going to have the same load because they have to be in a phase, so what is the system called again? I forgot, whatever. 3-phase, yeah, 3-phase. If you want to convert this into a Y, this is going to be ZY, ZY, and ZY. It is literally just Z delta divided by 3 is equal to ZY. There's nothing more to it. That's it. That's it. So I think this is enough to sort of get you understanding a bit more about 3-phase. I don't think I've left anything too important out. Here's VRMS, all of that. All of this you just derive on the exam. You can memorize this, but it's a I don't know why. I find it easier to just figure this out from first principles. So, again, I'm sorry for posting a footnote so late, and I hope this helps you on the final. Have a good day.